Welcome to the presentation for experimental design by Tori, Natalie, Olivia, Allie, and Scott. The definition of experimental design is that the researcher manipulates at least one independent variable, controls other relevant variables, and observes the effect on one or more dependent variables. The researcher has control over the selection and assignment of the groups to treatments. The independent variable can also be known as the treatment, the causal, or experimental variable. The change in this independent variable is what sets experimental research aside from other types of research. The dependent variable, also known as the criterion, effect, or post-test variable, is the outcome of the study, or what is changed due to the independent variable. This dependent variable must represent a measurable outcome. The purpose of experimental research is to produce the strongest evidence for cause and effect relations. So the best way to visualize this is by stating that if you use approach X, you will probably get different results than if you use approach Y. Usually, if this research is duplicated, it will yield the same results, allowing the researcher to generalize the results for the population.
There are two major classes of experimental designs: single variable designs and factorial designs. A single variable design is any design that involves one manipulated independent variable. There are three subtypes of single variable designs, which are pre-experimental, true experimental, and quasi-experimental. A factorial design is any design that involves two or more independent variables, at least one of which is manipulated. In the pre-experimental designs, the one-shot case study involves one group that is exposed to a treatment and then post-tested. No relevant threat to validity is controlled. The one-group pre-test post-test design involves one group that is pre-tested, exposed to a treatment, and then tested again. The static group comparison involves at least two groups. One receives a new or unusual treatment, and both groups are post-tested. Because participants are not randomly assigned to groups and there are no pretest data, it is difficult to determine whether the treatment groups are equivalent. In true experimental designs, they control for nearly all threats to internal and external validity. True experimental designs have one characteristic in common that no other design has: random assignment of participants to groups. Ideally, participants should be randomly selected and randomly assigned. The pre-test post-test control group design involves at least two groups, both of which are formed by random assignment. Both groups are administered a pretest, one group receives a new or unusual treatment, and both groups are post-tested. A variation of this design seeks to control extraneous variables more closely by randomly assigning members of matched pairs to the treatment groups. The post-test only control group design is the same as the pre-test post-test control group design, except there is no pretest. Participants are randomly assigned to at least two groups, exposed to the independent variable, and post-tested to determine the effectiveness of the treatment. A variation of this design is random assignment of matched pairs. The Solomon four-group design involves random assignment of subjects to one of four groups. Two of the groups are pre-tested and two are not. One of the pre-tested groups and one of the unpretested groups receives the experimental treatment. All four groups are post-tested. This design controls all threats to internal validity. For quasi-experimental groups, when it is not possible to assign subjects to groups randomly, quasi-experimental designs are available to the research. They provide adequate controls and threats of validity. The non-equivalent control group design is like the pre-test post-test control group design, except that the non-equivalent control group design does not involve random assignment. If differences between groups on any major extraneous variable are identified, analysis of covariance can be used to statistically equate the groups. In the time series design, one group is repeatedly pre-tested, exposed to treatment, and then repeatedly post-tested. If a group scores essentially the same on a number of pretests and then significantly improves following a treatment, the researcher has a more confidence in the effectiveness of the treatment than if just one pretest and one post-test were administered. In a counterbalanced design, all groups receive all treatments, but in a different order. The number of groups equals the number of treatments, and the groups are post-tested after each treatment. This design is usually employed when intact groups are included and when administration of a pretest is not possible. Factorial designs involve two or more independent variables, at least one of which is manipulated by the researcher. The 2x2 is the simplest factorial design. Factorial designs rarely include more than 3 variables. A factorial design is used to test whether the effects of an independent variable are generalizable across all levels or whether the effects are specific to particular levels. Features of appropriate research questions are focused on independent variables, which include the method of instruction, type of reinforcement, arrangement of learning environment, type of learning materials, and length of treatment.
All right, moving forward. Here are the key characteristics that are defining points for experimental research. The manipulation of an independent variable is the primary characteristic that differentiates experimental research from other types. An experimental study is guided by at least one hypothesis that states an expected causal relation between two variables. In an experiment, the group that receives the new treatment is called the experimental group. And the group that receives a different treatment or is treated as usual is called the control group. Basically, as a researcher, you will decide who gets what. You have control over the selection of treatment to each randomized group. The use of randomly formed treatment groups is a unique characteristic of experimental research. Control refers to efforts to remove the influence of any variable other than the independent variable that may affect performance on the dependent. This experimental research provides the strongest results of all quantitative research methods.
So the steps in the process are should be pretty familiar to most of us. I'll just run through them briefly, and the process steps are in bold and large letters, and keywords on this slide are in parentheses. So for the first step, selecting and defining a problem, the book talks about how that is the most difficult thing for most graduate students. So here are some 4 key words that can help guide how we can select and define problems. One is theory. Finding a theory we like and trying to apply that theory in different situations can create different opportunities for research. Or experiences. That's how I usually do my research, is through questioning of whether it's something I've read or something I've experienced myself. You could try to replicate someone's study, or just the library as you're reading or going through databases. For selecting participants and measuring instruments, it's really important to have a well-defined population. Just saying you're studying older women and their exercise would be inappropriate because of the large scope of older women. You need to define it by age or make it more realistic. It needs to be random, as we talked about earlier, and you need to have an appropriate measure decided. There's lots of designs for experimental design, and you'll need to know the one that fits your problem best, which ties right into the research plan to make sure that you're using the right measure. And this is basically just the introduction to your research. What method are you using? What type of analysis are you using? Is it realistic in time and your budget? And then you'll execute the procedures, and after that you analyze the data. And this is where we're looking at the dependent variable, because we have 2 different groups that we're comparing. We need to look and see the differences between the dependent variable outcomes. And to formulate conclusions is a process that requires statistics, because you could have a group that scores 27 in your experimental group and a group that scores 25 in your control group. How do you know if that's really statistically significant when the difference is small? And that's why we have statistics to help us determine whether that's really significant. So conclusions, while being statistically significant is important, it's also important to understand the difficulties with experimental designs before you make conclusions.
Okay, let's talk about potential challenges. First is the exposure to treatment. You need to have enough time of treatment to see if you have any changes. Another is make treatment substantially different. Then control the extraneous variables that affect the performance of the dependent variable, which are a threat to the validity of the study. We're going to talk about this in a little bit. And find the balance between control of all the variables and realism of the study. If you control too much the variables, then you cannot generalize all your results. So talking about validity. An experiment is valid if the results are a direct result of the independent variable, which means we are talking about the internal validity, and if they are generalizable beyond the experimental setting, which we are talking about the external validity. So there are different threats to this validity, and we are going to talk about them now. So threats to internal validity. Talking about the history is any event occurring during a study that is not part of the experimental treatment and may affect it. For example, an epidemic, or maybe you are testing teachers and they just found out that they are not going to receive their salary. So this might affect the outcomes of your investigation. Another thing is the maturation, which is physical, intellectual, and emotional changes that naturally occur within individuals over a period of time. So you are testing children, and they might improve their coordination just because they mature. You need to be aware of times and things like that, and so you can conclude that the manipulation of your variable made the difference or the outcome that you expected. Another thing is the testing. Maybe there can be an improved performance on a post-test that results from a pre-test. If the person is already aware of or might remember some things from the pre-test, that person might do better in the post-test. The instrumentation talks about the lack of consistency in measuring instrument. So if your pre-test is maybe more difficult than your post-test, then it's going to be difficult to measure the manipulation of your variable. The statistical regression is the tendency of participants to regress or move towards the end. So maybe the ones who score highest in an exam and the ones who score the lowest, they might tend to go to the middle. So you need to be aware of that. Another thing is the differential selection of participants, which is the selection of subjects who have difference before the study starts. If you have to choose a group that is already formed, then there might be certain characteristics of that group, and you need to be aware when you are reporting or presenting your results. The mortality is the reduction in number of research participants, so the participants that might drop out, and this actually affects your study when you didn't do a pre-test. Now we are going to talk about the threats to the external validity. So what is going to threat our study to make it general to all the population? It is the pre-test treatment interaction, where participants respond differently to a treatment because they were pre-tested. So they are aware of, maybe if you are talking about motivation, they are aware of that thing and they might react or respond different. Another thing is the multiple treatment interference, which are carryovers effects from an earlier treatment. So if you are doing multiple treatment, maybe after you do your first treatment, you will have some results, and then with the same group you are going to try another treatment. So they might remember, or certain things might actually come from your first treatment rather than your second treatment. Another thing is the specificity of your variables. So maybe you are having a very specific kind of participants, or the instruments or the circumstances are just too specific. Another thing is the treatment diffusion, which groups communicate with and learn from each other. So you have your control group and your experimental group, and they might actually, for example, in students, they might teach one another how to make, like maybe in mathematics, how to solve a problem, and then you will have a mixed intervention. The experimental research is that the researchers' influences on participants or on the study. So the researcher has an idea of the outcomes, so he or she might influence the study or the participants. And finally, the reactive arrangement, which is if you develop a highly artificial environment, or the participants change their behavior because they know they are in a treatment or an experiment. The John Henry effect, which members of a control group compete with the experimental group, and the novelty effect, which is increased motivation because participants are doing something different. So,
okay, thank you, and please leave any questions, comments underneath our video. Woo!